Hello everyone. In our previous video, I introduced about ray optics and we learned few of the basic terms related to mirror, and that was a spherical mirror. Today, before we derive the relationship between radius of curvature and focal length, that is already I hope you know r is equal to 2 times of focal length. We are going to discuss sign convention, that is Cartesian sign convention first. Here is the diagram: mirror, then an object and its image is formed here downward. You see center of curvature, focal length and P pole. Let's start with the first sign convention, that whenever we are going to place the object, it should always be placed on the left side of the mirror. So this is the mirror and the object is here. So this is the left side of the mirror. So that is sign convention first. Second sign convention, each and every distances which we are going to measure is from the pole. Suppose we are going to measure the distance of this object. So from where we will measure, we are going to measure from pole. That is from here. So the distance from pole to this object, we will denote it by u, and the distance of the image from the pole, we will denote it by v. See the third sign convention. So ray will go from left to right. So we are measuring distances from pole. So see the direction, ray is going in this direction from left to right. So this is the direction of ray which is going to incident on the mirror, and we are going to measure the distance from pole. So from pole to object. So see the direction of measurement. It is just opposite to the incident ray. So therefore this distance u we are going to write as negative, minus. So and similarly the distance of image, that is v, again we have written minus, because we are going to measure the direction, we are going to measure the distance in this direction, and light is incident in this direction. So what third sign convention says is distances measured in the direction of incident light. Incident ray is in this direction and we are measuring in this direction. So since both are opposite, so therefore it will be negative. And if the distance is measured in the direction of incident ray is going in this direction, suppose image is formed here. So this is the image. Now we are going to measure the distance from pole to this image. So this distance we are going to write positive. Why? Because see the direction of incident ray in this direction and image is formed here on the back side of the mirror, and we are measuring distance from here to here. So that is in this direction. See the direction. Since both the directions are same, so it will be taken as positive. Next, last sign convention, that is height above principal axis. So this is principal axis. So height above principal axis. So this height, which I have denoted by h, it is written positive. So height above principal axis, if you are taking height above principal axis, that will be positive, and below principal axis. So this is principal axis, see the height. So this is height of the image, I have denoted by h dash and written as minus, negative. Why? So this is the sign convention number 4. Height above principal axis, positive, below, negative. Now we are going to derive the relation between radius of curvature and focal length. Here is the ray diagram. When ray of light, suppose an object is placed somewhere at infinite and ray from that object is incident on the mirror and get reflected. Since light is passing parallel to the principal axis. So as rules already we have discussed, it will pass through focus. Once again, follow the laws of reflection. So light is incident on the mirror, and it is, since it is parallel, it will pass through focus. Next, let us pass a light from C. So see, if it passes through C, it will again return back through C, and this is always normal to the mirror. Whenever a ray of light will pass through C, it is always going to strike the mirror at 90 degree, at a right angle, always. Next, see, follow the laws of reflection. Incident ray, this is incident ray, and this is normal because it is 90 degree. Incident ray, normal, the angle between them is called as angle of incidence. Normal and reflected ray, the angle between them, it is called angle of reflection. So according to the rule of reflection, angle of incidence should be equal to angle of reflection. Therefore it is written theta. Again it is also written theta because these two should be equal. So angle of incidence theta and angle of reflection should also be theta. Next, by alternate interior angle, this angle and this angle. Since this is theta, so this will also be theta, alternate interior angle. Now we will use, this is theta, this is theta. Now this will become 2 theta. Why? Because this is an exterior angle of this triangle CFM. See this triangle, and this angle is exterior angle. So therefore exterior angle is what? Sum of two interior opposite angles. So this theta plus theta will become equal to 2 theta. Now we will use tan theta in this view of the triangle. First triangle we are going to take is, and before we discuss that, one assumptions we have taken this aperture. Aperture we have taken very small. The aperture of the mirror is taken as very small. Why? So that this distance DF or PF can be same. We can take same, means this distance we can neglect. This distance, small distance, so that we can neglect. So that is why this aperture is taken as small. Now let us use tan theta in triangle CMD. So in triangle CMD, let us write tan theta. So tan theta is what? Opposite upon adjacent. See the opposite. So this is opposite MD upon adjacent. So the CMD. So opposite and adjacent. So adjacent is CD. So right here CD. We can write tan theta as equal to theta. Why? We can write tan theta is equal to theta because we have taken aperture very small and angle of incidence we are taking very small, so that tan theta can be written as theta. So here I write theta can be written as theta, can be written as sin theta, when if theta is very small. Now again we will take triangle FDM. Triangle FDM. Again we will write tan theta. See here angle is 2 theta. So you write tan and theta is 2 theta. So tan, the definition is opposite upon adjacent. Opposite is MD. See this triangle MD, and adjacent is FD. Again theta is very small, so therefore 2 theta again very small. So this can be written as 2 theta is equal to MD upon FD. Equation number 2. Now from equation number 1 and 2 we can write from equation 1 and 2 we can write, what we can write is 2 into, in place of theta we will write from here, theta is equal to what? MD upon CD is equal to MD upon FD. So from equation number 1 and 2 what we did, here 2 we have written as it is, in place of theta we substituted this value, that is MD upon CD. So MD upon CD, and on the right side same, MD upon FD. Now from both sides MD and MD is cancelled. So 2 upon CD is equal to 1 upon FD. Now observe the diagram. What is CD? From here to here CD. So CD we can take approximately equal to CP. Why? Already I told aperture is very small, so this distance can be neglected. So what is CP? The distance from center of curvature to the pole is known as radius of curvature. So that we will write 2 upon R is equal to 1 upon FD. What is FD? FD. So FD is nothing but focal length. The distance from focus to pole will be called as focal length. So right here F. Now do the cross multiplication. Next step, do the cross multiplication. So R is equal to 2F. F into 2, 2F, R into 1, R. R is equal to 2. So this is a small derivation for relation between radius of curvature and focal length.